Everyone, so this is my first go at making a YouTube video here, going through data challenges. So we're going to start with data challenge 3. I'm going to try not to spend too long on it. Be sure to pause it along the way as you need, and then be sure to give me some feedback if you want to see me do anything different. So the goal of data challenge 3 was to go through a data set that was about university graduate admissions that then has a bunch of data on different scores. So GRE scores, TOEFL, which is basically an English language score, taking a test on that, GPA, letters of recommendation, a couple other things. The main goal was, though, to identify errors that exist in this data frame after you input it, and then using an existing function within read CSV to then go and automatically change these to NAs. And so you'll see why NAs are better than, say, non-NA values, given the different things you can do with them. So as with any data challenge, and anytime you're working R, we have our script here on the right-hand side of the screen, and then we have our console right over here. And so you always got to load in your packages first go. So run this line here, just to make things easier. What I'm going to do is clear my console here. So go ahead, run our library tidyverse, and then this way our library is open so we can go and use the functions that exist within tidyverse. Remember, we went through class and there's a couple different ways to bring in data. One is the file path. The other is using stuff from the web. But those are both sort of tricky in their own ways. And so we're going to use the simpler way, file.choose, which opens up a graphic interface. And so you can see this is two nested functions. File.choose is a function in and of itself. And we're putting that inside read CSV, which is another function. So you're saying call read CSV as a function and then find a file for that read CSV to look at. So we'll run that. And then here we get our pop-up, which I think you can see. And then we're going to have admissions dirty. So that's the name of the data file, or at least what I named it when I downloaded it from the web. So right away, you can see some interesting things here. And this is one of the things we talked about today and a couple other places. So you can see what type of data has been brought in. It's telling you all the columns that exist here in the data frame. And it's telling you what they are. So here, column double, what that is referring to is a number with a decimal place, or just a number in general. And so what this means is that read CSV went and brought in this file, and it recognized that all the values in a given column were numbers. And so it's making that R, it's allowing R to know that it's a number, so it will work with it like a number, add, subtract, do whatever you want. Other ones, though, it's seeing that, hey, there's text in here beyond just numbers, and then it's just saying it's a character, right? So this is a string of values that could be text, or it could be text with numbers, whatever. Whatever the case, so you can't then on character strings go and say do math. It's not going to know what to do given it's, well, text. And so there should be some clues here that should kind of throw you off. So if we look at, say, glimpse of our admin data. So we see, for example, that despite GRE score should be numeric, it's importing it as a character. And to me, what this suggests is that there's a letter or a symbol or something in there. So R, when it's importing this whole column, it's going and saying, hey, number, oh, character. And so we should then assign this all as a character rather than a number, given number string should have characters in it. So these are kind of things you can use to be like, hey, maybe this actually should, be a double or, a number rather than a character string. We should look for errors in there. TOEFL score falls into the same category, right? So here, this is being imported as a character. You can see that also reflected here in glimpse, CHR. And right off the bat, it's kind of nice. We can see some question marks, right? So there's some missing data here. If we keep on going down the rank, down the rows, we see a lot of doubles here that should be doubles. And so these seem to be okay, but we'll want to look at them more. Research is being imported as a character, but this actually should be, right? So it's yeses and nos. And so what we're going to do is we're going to go through and we're going to go and look for any values that shouldn't be in there. And so this is a kind of a time-consuming way to do it, but we're going to do it anyway just for the sake of simplicity. So as you all have gathered, I really like unique, but you could do other things. So you could go and say call head, right, which is normally the first 6 values, admin, and let's look at GRE score. And what I'm going to do is also I'm going to ask for, instead of just seeing 6 values, I'm going to ask for, say, 30 and close that. And so now it's giving me 30 whole values. And so that's actually really nice because you can see deeper in and you're like, all right, so we can see this dash, dash, dash. And so it's pretty clear that that's probably the weird symbol in here. We can also go ahead and do our unique, which I obviously also love and use all the time. So this is going to ask for any unique values of whatever column you feed it. So in this case, admin, GRE score. So let's look again, just in case there's anything else in there. And so you can see this is mainly numbers, but we do have our 1 dash here. And so we can go down here and just make a little note for ourselves. So we have a dash. And let's kind of now go through and look at our other columns. And so we know TOEFL score looks to have some errors, so let's run that. Okay, again, we get some question marks. What are our other ones in here? So uni rank, these are numeric, and yet we're seeing that this is a character string, so that also suggests there's probably an error in there. Admin, rank, run that. Okay, so no rank. So someone, when they were inputting this data, they didn't actually find the value or whatever it is, and they're just giving it a value of no rank. They just type that directly into the Excel sheet. It's important that you actually do this directly, that you copy this directly, and don't put any improper symbols or spaces or anything in there. Otherwise, R won't be able to do it. And then our last issue is, let's look at, I think, the research. I should know what these are. I might have messed them up myself, but let's just double check. Research. Yeah, okay, there we go. So we have this in 3 question marks. So you're going to actually need to make sure that you put them in this as a different symbol, because R will view 3 question marks in a row differently than that. And so what we're going to do is, now we know what symbols we want to assign to. Instead of being those symbols, we want them to be NA values. And so we're going to use our read CSV with file choose. But with most things in R, you can feed multiple arguments that can customize how something acts. And so in this case, we're going to do a little comma. And then in NA, we're going to replace this, and we're going to make a list of everything that are all the bad symbols that we want to replace. So you start with C, you open your parentheses, and then you're going to go and put in quotes every individual value. So we have a dash, we have 1 question mark, comma. So you always want to separate by commas, 3 question marks. And then finally, we have no rank, no rank. We're going to run this line again. It's going to tell us, hey, bring your data back in because we're not using a file path. Admissions dirty. And so cool. So what we're seeing is everything just converted to doubles, right? So instead of before it was bringing these in as characters, it now recognizes, hey, there's only missing values, which are NAs, and numbers. So we can say that that's a double column, right? Or the column is a double, it's numeric. We can now look at it again, just check it out, glimpse, admin. Okay, and so now you can see we're seeing these NA values. There's some other things that you can do to tell, right? So if you do summary, which some people like, I also like it, admin. What we see here is that also, you know, that this is like kind of why the NAs are so important, is that it's able to then do math around it. So for GRE scores, we can see there's 30 NA values, but those don't stop it from actually calculating summary statistics of the min, quartiles, median, means, so on and so forth. And so this is one of the reasons why NAs are so helpful, is you can then go and calculate these values without throwing R off. If you try to calculate a value where it was still a character string, say a mean, it's going to break it, or not break it, but it's definitely going to throw errors and not calculate it. So here, check out head again to see, now that we have NA values, we can just do that quick. Admin, run it. And so you can also see, here's the NAs highlighted in red. So cool. We now have our data in, and this is just a really helpful way. You can imagine that if you had, say, 30 or 40 columns where someone was putting question marks or something like that in, it would be really tedious to go through to every column and replace those values, which we're going to do in data cleaning. So it's much easier if you kind of have these kind of known issues to just go ahead and do it right off the bat on data import. And so that's where we are now. So now we have like a nice working data frame. And here what it is now is that you can go ahead and let's use some nested functions. So nested functions are just a function within a function. We were doing that whenever we're doing this. File chooses a function and you're putting that within read CSV. You're using the function file choose within that. And so if we want to explore how many NA values, sure, on one hand, we can just see it right here. And that's useful just to give them a quick idea. But you might actually be working with something where you need to, know the actual percentage. And you don't want to just simply copy this out and do your math, say here in the console, like 450 divided by 500. Because if your amount of data changes, that'll change too. And then you don't want to go through and punch that through every time. So you can remember that is.NA is a function in and of itself. And so we want to go and see how many NA values are there within the columns that we know have NAs. So GRE score. And so if we just do this single function, GRE score not found. So the reason why that wasn't found was I didn't tell it where to find it. You got to look at admin. So what that does is it kicks back all of the whole data framework. So here's 500 lines. I will stop at 1,000. And it goes through to each and every one and says, is this an NA? And so you can see the fourth value in of GRE score is an NA, which you can see here, the fourth value in is also an NA. So it's going down this whole column and asking, is it an NA, is it an NA, is it an NA? And in this case, false, false, false. So if we want to count the number of NAs, you remember that what we can do is just count the numbers of trues and falses. Falses are 0, trues are 1. So we can wrap sum around this. So sum is NA, and we get 30 as our value. So there's 30 NAs. And so let's go now to the other columns that we know had issues. So we know that we had TOEFL score. So we can do sum is NA, admin, TOEFL score. We also had uni rank, if I remember right. Sum, admin, or uni rank, 25. And then the last one was research. Sum is NA, admin, research. Okay. So like, why is this useful, right? Like, why do we could just go and use like the summary straight away and look. And sometimes you might want to just look at the summary and just be like, all right, there's not that many NAs. But it's not uncommon, and that's kind of what I'm getting at this question, is that you might want to say put like a metric in place to be like, if I have this percentage of NAs, so whether you have 100 data points or 1,000,000, you only want to say use something if you have a certain amount of data that's not missing. And so I'm setting this threshold of say 10%. We only want to include data that has 10% or less missing, right? And so most of the columns we don't have to check, but some of the other ones we do, specifically all the ones we know have missing data. And so a percentage of something is nothing more than, in this case, the number of NA values over the total number of values. And so there's a lot of ways you can get the total number of values. The easiest one is just the number of rows in the data frame, right? So n row admin. And so that's 500 right there. And so the percent missing is going to be however many missing NA are over 500. So the reason why we don't want to just go and do, like, say, 30 divided by 500, because after all, these numbers are right here, is that this number only works once, right? And so we see, okay, there's 6% missing value, so 0.06. But the problem here is that it only works once. So if I say updated this and now you have 550 values or 1,000 values, what you would need to go through is calculate this, look here, and get the updated value, and then also run n row again and get the updated value. So you'd have to delete this, and be like, oh, now there's 35 and 1,000. And that's not like the point of R. The nice part about R is that you can automate these things. So if we instead do sum is NA admin GRE score, And then we can divide that by the number of rows, 500. So n row of admin. And then just for cleanliness sake, we can just make whole percentages. So multiply by 100 and run that. And so what we see is 6. So 6% is missing. So if I ever go and change the amount of data that is present, increases or decreases, you don't need to go and manually calculate everything again. You can just run this and it will automatically do it for your updated data set. So this is sort of why you want to avoid using the raw numbers and instead use the code to calculate those for you directly. So what we're going to do is we're going to go through. I'm going to be real lazy here, and I'm going to copy and paste. This is a good way to create errors in your code, but I'm trying to make this not too long. So TOEFL score, and then we want to do uni rank, and then what do we got? Research. So let's go through and run these other ones. 90, 5, and 11. Cool. So I'm saying the threshold is if there's 10% data missing, that we don't want to use those columns. And so we can see here that our research column has 11% missing. So that's right on the edge, but hey, our threshold's 10%. That's what we're going to stick with. And of course, TOEFL score is pretty worthless. We're missing, we only have 10% of the values. And so this could be because, hey, maybe only 10% of the people took the TOEFL, or it could be that, only 10% were reported or something like that. So overall, we don't know why the data aren't good, so we're just not going to use it. Okay, so we now have our percentages. We know what columns we want. We know what columns we don't want. And so we can look back at, say, the summary of our data, the head of our data, admin. And now we're going to use our select function. So if you remember, this is a tidyverse-based function, and so we have this nice format. So we're going to create an object called admin clean. And so this now is going to be a sort of cleaned, reduced version of it. And we're going to use the function select just to select out the rows we want. So admin clean is what it's going to be called. You have your assignment arrow, and the data that you're going to work from is just our whole data frame, which is currently admin. So you're going to take admin, use your pipe, then you're going to select things. What are you going to select? Well, the rows we care about. So the serial number in X1, we don't actually care about those. Those are just like a sequential thing. I don't know why those are in there, so we're just not even going to bother with them. So we're going to ditch those in the 2 columns that have over 10% missing data. So that means we're going to keep GRE score. We're going to keep uni rank. We're going to keep SOP, OR, CGPA, and chance of net. Cool. So let's run that. And so now we can do like a quick comparison just to make sure that this actually did reduce the number of columns. You can look at head and clean. Cool. So this is great. So now we're down to just 6 columns, right? Of only the data that is relevant, that has enough data for us to make inference from. And so we can kind of move on and just keep working with admin clean. So here now is where, kind of my fun questions now start making some inference with this. So we have the clean data. And so let's take a step back and be like, all right, well, you want to know what are some of the best predictors of getting into graduate school. And so in this case, that means we want to predict our Y, chance admit, as a function of, let's say, GRE scores here. So we can just go ahead and run this and look at the plot. So one thing you can see here that's kind of cool, so warning message, remove 30 rows containing missing values. This is like why it's so nice to have actual NA values, is R will be like, hey, there's some missing values and we worked around them. Obviously, this is really helpful that it can do this. Makes the process a lot faster. So we ran that figure, and so what do we see? We see this nice, real positive relationship between the chance of getting in and your GRE scores. And so this isn't surprising. If you do well in the graduate exam, you have a higher chance of getting into graduate school. There's some other kind of like neat things that I like to look at, right? So if you do really well in the graduate exam, right? So you're over here at a 340 at a GRE, your chances of getting in are just always extremely high. There's not a lot of variability. Um, if you go down here, and let's say you did, say, more poorly, say in the 300, you start seeing more variability. Some students actually still have a pretty high chance of getting in. And this could be because, say, maybe they have really good letters of recommendation or a good GPA or something like that, where other ones have a much lower chance. And so what you can kind of see here is obviously the better you can do on your GREs, the better your chance of getting in. But just because you didn't do well doesn't mean your chances are very low of getting in. You could still do poorly, in quotes there, and still have a very good chance of getting in. So I did very poorly on my GRE exams, but I had other good things that helped me get in. So if any of you are taking those, don't worry too much about them. Of course, study, but it's not the end of the world if you don't ace it. Okay. So we looked at that, and since this is a data challenge, we can go ahead and say, look at a few other things. And so, we can come here and say, let's look at, instead of GRE scores, we have some other good values. So let's look at GPA. Probably GPA, you would assume someone's going to do, if they do better on their, or have a higher GPA, they'll also have a higher chance of getting in. So GPA, just change that quick. And what do we see? A couple of things. So for one thing that's nice, notice I didn't throw any warnings. It's because we didn't have any missing data in GPA, right? And so I didn't have to throw any warnings. And then when you have this GPA, so 10 being the max, we see the same pattern, right? There's a lot of variability if your GPA is a bit lower, but if your GPA is really high, you're like essentially guaranteed to get in. And so that's like pretty good for now. So yeah, so that's the data challenge. I hope this was helpful. Again, please feel free to watch this, rewatch it. Also, I'm more than open up to feedback of things that you would like me to do differently on these. So be sure to let me know in class.